Hello Year 3 and Year 4. Welcome back to our science learning. We are going to continue looking at states of matter, and today's learning intention is I can observe and measure. So at the end of the last session, I showed you a little investigation you could do where we put some vinegar in the bottom of a bottle and we put some bicarbonate of soda in a balloon. And then you flipped up the balloon so that the bicarbonate of soda fell into the vinegar, and I asked what happens next. Now, some of you have managed to do this at home and sent in some fantastic pictures and videos which look amazing, but that's okay if you didn't manage to do it because I said I would share my results, and here they are. So here is what happened. So what's happening here is that when the bicarbonate of soda and the vinegar are mixed together, it creates a gas called carbon dioxide, and the gas begins to expand in the bottle and it inflates the balloon. If you didn't have a chance to do this, then do give it a go if you get time, because it is a lot of fun. Now, also at the end of the last session, I showed you these pictures, and I asked which of these pictures do you think represents a solid, a liquid, and a gas? Is it possible for material to change state? What do you already know about materials changing state? Well, this picture here represents a solid. So the particles that make up the solid, remember these are really super small that can't even be seen with a microscope, and they are vibrating, but they are held in a fixed pattern, a bit like children all sat in a classroom. And this picture shows a liquid. And in here, the particles are still quite close together, but they're moving around in a random fashion, and they are slightly further apart and more free to move, maybe like children having a PE lesson in the hall. And in this picture, this shows the particles of a gas, and here you can see that the particles are separated. They're quite far apart and they're moving about in every single direction at great speed, a bit like children in the playground at break time. So what makes materials change state? So materials can be in three different states: solid, liquid, or gas. But how do materials change state? Have a look at the diagram opposite and choose the correct labels for each arrow. So we have some water and we have some ice, and we have some arrows showing ice becoming water and water becoming ice. Do you think which arrow do you think should be labelled freezing and which should be labelled melting? Okay, so this arrow is labelled freezing because the liquid is frozen to become ice. And this arrow is labelled melting because the ice has melted to become liquid. When a solid turns into a liquid, it is called melting. The temperature at which a solid material melts is called its melting point. Different materials have different melting points. If a solid material is heated to its melting point, it will start to melt and it will change state from a solid to a liquid. In a solid, the particles are closely packed together and are vibrating on the spot. When a solid is heated, the particles start to move faster and faster, and if enough heat is applied, the particles will have enough energy to move about. They are still close together, but can move over and around each other, and at this point, the solid has melted to form a liquid. But when a liquid turns into a solid, it is called freezing. The temperature at which a liquid material freezes is called its freezing point. Different materials have different freezing points. It's important to remember that some materials have freezing points above 0 degrees Celsius. For example, the freezing point of iron is around 1550 degrees Celsius. Above this temperature, it will be liquid iron, but below this temperature, it will be solid iron. If a liquid material is cooled to its freezing point, it will turn from a liquid to a solid. The particles in a liquid are close together but can move quite quickly around and over each other. As it is cooled, the particles start to slow down. Eventually, they slow down so much that they only move gently on the spot and a solid structure is formed. The material has frozen. So for most materials, their melting and freezing points are the same. Although it sounds strange, think of the melting and freezing point as a barrier. If the material is heated to a temperature that's higher than this, it will melt. If the material is cooled to a temperature lower than this, it will freeze. So on this picture here, we can see here is ice, because we're looking at water, and then we've got water as a liquid up here, and 0 degrees Celsius is the melting point and the freezing point. So my friend Dave thinks that all solids melt at the same rate. Well, how could we investigate this? So one way that we could investigate this, and this is how we're going to look at it today, is we could take some different materials. So here I've got butter, ice cubes, cheese, chocolate. We could heat them up, and then we could time how long it takes for them to melt. So to do this investigation, what are we going to need? What equipment do we need to have so that we can carry it out? So we're going to need some materials to melt. Now you could use ice or butter or chocolate or cheese like in the last slide. You could also use wax, would work as well. We're also going to need a container to melt the materials. So this could be a saucepan or a bowl. We're going to need a heat source. Now this could be a hob or it could be a microwave. We're going to need a timer, and a stopwatch is perfect. And we're going to need to record our results. This could just be on a sheet of paper. And we are absolutely going to need a grown-up to help you, because this investigation involves using a heat source. You must have your grown-up with you to do it. So how can we make sure it's a fair test? Well, here are some ideas. Do we need to keep the heat source the same? Do we need to keep the container size the same? Should we test solids that are the same size? Do we need to use our timer accurately? Do we need to record our findings accurately? And is there anything else we can do to make sure it's a fair test? I'll let you have a think. So here we are, I'm getting started. I've had a go at this at home. So I've decided I'm going to conduct my investigation using a saucepan, which I'm going to put on the hob. And I'm going to look at the melting points of butter and an ice cube. Now you can do more than this if you want to, but you must do at least 2 because you need to be able to compare them. I'm going to write my results down on a whiteboard that I have here, and I've got the material I'm testing, and I'm going to record in these boxes the time it takes to melt. And this is my timer. I haven't got a stopwatch, but I did find one on my phone. So you might find one on the phone, or the other thing that you could do is you could count the second hand on a clock. That would be fine too. Okay, so then I put my pan on the hob. First of all, I did the ice cube. So I put it on and I timed how long it took before the ice cube went completely to a liquid. And then I stopped my timer and I wrote down how long that took. And then I did the same with the butter, and I waited until it had become entirely a liquid, and then I recorded how long that took. Okay, so now it comes to the point where we need to write up our experiment. So a worksheet like this will be attached to the assignment, and you need to write in the date. The learning intention is already there, and I filled in the first part for you, which is the aim, to find out if solids melt at the same rate. Now the first thing you need to do, now this is before you do your experiment, you need to write a prediction. So you need to say what you think is going to happen. And it might be that you think that butter will melt more quickly than ice, or it might be that you think they'll melt at the same rate. It could be anything. Next, you need to record the apparatus you are going to use, such as a saucepan, the materials you're going to melt, and how you're going to time it. Next, you have your method. Now, this is where we say how we're going to make sure it's a fair test. So you need to say what you're going to do and how you are going to make sure that you are conducting a fair test. Finally, well, not finally, but here we have, you need this section where you need to write your results. Now, I've done mine in a table because that's how I recorded it on my whiteboard. So you could do the same, or you could just write out your results. If you are in year 4, We've just started our new chapter in maths on graphs and bar graphs, so you could record your results as a bar graph if you wanted to. And finally, you need to write your conclusion, which is where you say what happened and why you think it happens in that way. You might also want to include something about what you would change next time you did this experiment. Okay, so here is a final challenge for you. Now, my friend Sam says that if he continues to heat each substance, they will all eventually change state and become gases. Is he correct? Always, sometimes, or never? Well, I'll leave you to have a think about that. I hope you enjoy your science investigation, and I will speak to you soon. Goodbye.